And welcome to another episode of the Concrete Logic Podcast. And today I got a returning guest. It's Mark Chase from RPX Technologies. Mark did episode 7, and we just recently released 66. So it's been a long time since Mark and I caught up with each other. Mark's here to talk about maturity meters, and we're going to talk about what those are and how we use those, and to get everybody back up to speed on that, since it's been a long time since we talked about that subject. But before we get started, just a reminder, everybody, how the podcast works. If you get any value out of this podcast, there's 3 things I ask, or 3 options you can do to help the podcast. So if you get some value out of this, think about these 3 things. 1, share the podcast. So if Mark says something today and you're like, hey, that's a pretty good idea, you can steal it from Mark. But the deal is, you got to share it with somebody. Or if you go to our website, concretelogicpodcast.com, and you go to the homepage, and in the bottom right-hand corner of the page, you'll see a microphone. You can click on that microphone, and what it does is you talk into your computer, records a message, and it's like leaving me a voicemail. And you can either ask a question or maybe suggest a guest. That would be very helpful. So that's another way you can help the podcast out. And then the third way is, again, on the homepage in the upper right-hand corner, there's a button that says donate. And what you can do is click on that button, and it will give you options to donate to the show. And again, if you get any kind of value out of the podcast, you got those 3 options. And if you do decide to donate, it's any amount you want to do. Any amount is appreciated, and it just helps us keep going. So again, those 3 things: share the podcast, and then you can get on the website and shoot me an idea on an episode, or donate to the show. Appreciate everybody's support. With that, Mark, we'll get started. Mark, you're in the maturity meter business, and you're an expert. That's why you're on this podcast. No pressure.
Expert might be a stretch, but okay, I'll take it.
Can you explain the principle behind it? What are these meters? What do they do? And then we'll go from there.
Sure. In essence, maturity meters are a way to determine real-time strength as concrete is cured. They are used in lieu of early construction cylinders that are taken. And in essence, you are taking a measurement of time and temperature and comparing that against a standard for that mix design. And out of it, you can get, as I said, a real-time strength number at any given time. So
right.
in terms of efficiency, it allows you to be proactive about those early construction activities, as opposed to reactive as to what a cylinder break is going to tell you.
Right. Based on, if you set it up right, the system right, what you're saying is you can actually project the strength of the concrete based on what the temperature reading is when you're looking at well, let's talk about what they physically look like. So these meters you actually stick into the concrete, right? What does that look like?
If anybody's old enough to remember what a 35 millimeter film canister looked like, so it essentially is, it's just a small sensor that has a few things inside it. It has its own power source, has its own battery. There's a microprocessor. There's a thermistor, a way of gauging what the temperature is. And then that gets embedded in the concrete, sacrificed inside the concrete, and then there's a couple of wires coming out of the concrete. So that is how it looks. And then those 2 wires, they connect to there has to be a way of getting the data from that sensor up to the cloud. And that is through a couple of different ways. In our case, we have 2 different methods. There's a handheld reader that you can use, or there is an autonomous way to where those 2 wires connect to a remote radio, which then through an RF radio process, that information from the sensor gets automatically uploaded to the cloud.
Okay.
And
Yeah. So there's an app maybe you can have on your phone, and that'll tell you what the temperature is for that specific meter, right?
Correct.
Okay. And then as far as where we put these meters, is there where do you put them in the concrete? Do you tie
If
them
you're
to the
if
rebar? Where would you
Sure.
put these things?
If you are using these for maturity purposes or the real-time strength purpose, then you would want to put them in the most conservative spot possible in your placement. And I'll give you an example. If you were doing a post-tension deck, you would want to place these in areas where it's going to be the coldest spot possible. Because if that is up to strength or up to temperature, then everything else theoretically should already be there. So that in most cases is going to be out towards the edge, up towards the surface. And then what people do is they'll, if it's a wired sensor, they will run that wire up column rebar if there's a column out towards that area, just to get them out of the way of the finishers. But
Yeah.
it's going to be in the least likely place to where concrete strength is going to be gained in the longest amount of time, or in
Right.
the shortest amount of time. Yeah.
Okay. And so not listeners of this podcast know this, and folks in the industry know this, but not all concrete is created equal, right? So you can't just, this is not just like a plug and play kind of thing. You don't just put those meters out. You decide
That is
on
correct.
you're starting a job next week and you're pouring concrete, and you got some of these meters, and you decide you want to put them in the pour, and yeah, I'll tell you the temperature, but it's not going to tell you a whole lot more than that,
No,
right, Mark? Because you got to
that
do
is
some prep.
correct. Yeah, there is a little bit of legwork that has to be done before. In best case scenario, that you have to develop, in essence, what is a heat of hydration curve of that mix design that you're going to use, or it's called a calibration curve. What that entails is the sensor itself is not recording actual strength. It's recording a time and temperature measurement, or a Celsius degree hour. What that Celsius degree hour then will match up to a specific PSI. In this beforehand work, there has to be some collaboration between the testing lab, maybe the ready mix company. If there's a concrete sub or a general contractor involved, there has to be a meeting so that everybody is in compliance or in agreement that this is the way that we're going to estimate our concrete strength. So at the outset, according to ASTM, there is a process of taking at least 17 cylinders per mix design. 15 of those cylinders are going to be broken in sets of 3 at given intervals, say at 1 day, 2 day, 3 day, etc. The other 2 cylinders get sensors placed in them. At the time that they break that first set of cylinders, they will be taking maturity readings off the 2 cylinders that have sensors in them, and that becomes the first point on the curve. And then you'll repeat that process until you run out of cylinders to break. So when you get done with that, then that curve has been established for that mix design. Maturity is a mix-specific operation. As I said, each mix design has its own unique heat of hydration curve that goes along with it. And what people can do in this case is they can be choosy as to which mix design that they're going to use based upon what kind of schedule that they have for this project. If they have a very rushed project, or a timeline that they need to conform to, then they can choose a mix design that maybe has something else in it that will make that concrete come up to strength faster. Or if they're not in that big a hurry, conversely, they can choose a mix design that has a little bit less of something in it that allows that concrete to gain strength in a longer period of time.
So what you're doing is you're measuring temperature and time and strength ahead of time before you start a project, and you're breaking these cylinders, and again, how much time it's been, what's the temperature of the concrete at the time you break it, right?
Yes.
And then the strength. So you're recording those, and then and you do it over a certain amount of time. And like you said, 1 day, 3 days, 7 day, 28 day. So based on that, that creates if you put that on a chart, it creates a curve. So you're able to see how the concrete gains strength over amount of time based on temperature. And then knowing that information ahead of time, you can, when you're actually out on the project and you're actually pouring concrete and you have these meters in the concrete, you can, based on what the meters are reading, you can essentially project what that concrete strength is, right?
That's correct. And the whole point of this thing is that the more massive concrete you have, the more it's being affected by ambient conditions. In the summertime, you're going to have hotter temperatures in the structure as opposed to in a 6x12 or 4x8 cylinder. And everything is based on temperature. So if you have elevated temperatures, the less time it's going to take for that concrete to cure or reach those thresholds where you can start post-tensioning or remove shoring, et cetera, et cetera.
Yeah. So remove, yeah, that's the point, or pull post-tensioning. So PTs, usually there's a certain amount of strength that has to be gained in the concrete before you can pull PT. That's right. Why I've used it in the past. And like you said, too, shoring, there's requirements and specifications that say, hey, you got to reach a certain strength before you can remove the shoring. So it would be useful for that as well. Because what we usually do is we break the actual cylinders. So you wait for the third-party inspector to break the cylinders to relay to everyone what those concrete breaks were. And then we can get into all the moaning and groaning and complaining that we hear within the industry about how folks treat cylinders. And this is a way for you to maybe mitigate that issue. In this technology market, we talked about this when you were on before, but it's been around for a long time. This is not something new, right?
No, it's been around for decades, and it's just within the advent of microtechnology that you've had the ability to place what essentially is a mini computer inside the concrete.
Maybe people are thinking about this. They haven't used this technology before. So what we're saying is to use the maturity meters, you got to do this work ahead of time, ahead of the project. And you're taking cylinders in a lab, right? Maybe at a ready mix supplier's facility. And how are we making sure that the readings are going to be correct? How should we be treating those cylinders at the ready mix facility where we're taking these cylinders ahead of time? Yeah, because we could treat those wrong and get bad data, right? And then this whole process is foobar.
Sure. Well, for one thing, any cylinder that's taken on a construction site, whether you're using, maturity sensors or not, any cylinder really has to be treated according to what the ASTM for curing cylinders is, and I believe that's C31. And that for the first 24 hours, at least, they are contained in a temperature-controlled environment to keep them between 60 and 80 degrees. When you're talking about creating a calibration curve, absolutely, you do want to have certain safeguards in that those cylinders aren't just sitting out in the sun or sitting in a pile of snow. Typically, what happens is, depending upon the actual project, sometimes a ready mix truck is sent over to the testing lab to where they'll take all 17 cylinders. That way, there will be no issues with transporting cylinders at that. If your first interval break is at 24 hours, there'll be no issues with transporting those cylinders in that first 24-hour period.
Every job that you want to do, Mark, everyone's on board, right? You go up and say, hey, I got these maturity meters, and they do this awesome thing. So how for folks that haven't used it before, talk about your experience and how that all operates.
Typically what happens if somebody is on the fence or like say a structural engineer or a general contractor or whoever it might be, what has to happen is that maturity meters are used, a calibration curve will be done, but at the outset of actually pouring concrete for the structure, both things will be done. You'll place sensors in the maturity sensors in the concrete, but you'll also take those field cured cylinders, maybe for the first 1 to the first to fourth pour of the project, so that then people can get an idea of what the difference is between taking a cylinder and taking measurements with a maturity sensor. Yeah, there has to be some level of confidence in that you're getting accurate data from the maturity meters.
All right. And if you're thinking about using it too, I haven't been on a job yet or looked at a job yet that only has one mix design. So when you're thinking about this, you got to do it for each mix design, right, Mark?
Yes, correct. Right. Like I said, the whole premise of the concrete maturity is that it is mix specific. So each and every mix design has its own unique calibration curve.
All right. So I think we rehashed what it is, right? Is there anything else before we move on? You think we didn't cover just the basics of what the technology is and how it's used?
I just want to, sure, just a general point of using maturity meters can make your operations more efficient. And in this day and age where just about every single project is on a fast track schedule, this is one way to ensure that you keep on schedule with the concrete part of the project.
Yeah. I was thinking too, because we're going through a period here where we're using new materials, new cement, new fly ash. So there's a lot of testing going on right now anyways. So if you're getting into a new project that's using new mix designs based on maybe, I don't know, some carbon footprint or global warming potential requirement, you're going to have to be doing this testing anyways. If there's an opportunity to use maturity meters in at the same time as testing these new concrete, I think it's valuable data to have. I'm sure Mark will agree with me because he's selling this stuff for a living, but that's what's coming through my head right now is we're going to be doing a lot of testing with these new materials anyway. Mark, are there companies out there, ready mix companies, contractors out there that just do this as a standard? Like they're taking this data all the time, temperature, strength, just as a standard that they do on every job?
Yeah, I think a good way to answer that question is to tell you that when I first started doing this almost 18, 19 years ago, I used to just chase tower cranes in whatever city I went to. And you come barging onto somebody's job site with something that looks like an M80 firecracker. And you try to explain what the whole maturity process is. So at that time, maturity, even though it had been around for decades, maturity was more state-of-the-art technology, to where now you have mix companies that keep a catalog of different calibration curves for those mix designs that they will generally propose to be used on certain projects. In this day and age, in some parts of the country, maturity is more state of the industry now, to where companies, and I'm not going to mention specific companies, but yours, for instance, Baker, will use this more often than not because it gives them sometimes an advantage over competitors when it comes to bidding projects. You can maybe get a project done sooner or get the concrete part of the project done sooner than, say, somebody else.
But like you said, you shared earlier, was you got to get everybody on board with it. GCs, the structural engineer, they all got to be comfortable with it. And there's different ways you can do that. In the past, I've broken cylinders the standard way, the traditional way, along with the maturity meters, and showed that the technology works. So you can actually say, hey, when we break that cylinder on that pour we did last night, it's going to break at this before they break the cylinder. And then when they break the cylinder and it lines up, then you can say, see, it works. It works.
Yeah.
So you can do that to convince if you got some folks that are new to it.
Yeah. And I should add, with the technology of today, you can more or less have your concrete talk to you. In this autonomous world that we live in, the sensors are continuously collecting data. That data is continuously being uploaded to the cloud. And then you can set your cloud software up to notify you once you reach certain thresholds or certain times that, like strengths, that you can start post-tensioning. At 2:00 in the morning, you might get an email or text message saying that the concrete that you just poured the other day is ready to ready to go.
You wanted to talk about a little bit about mass concrete too, other than the post-tensioning and formwork applications you were saying that used for mass concrete.
Well, just in the past little while here, maybe the past 2, 3, 4 years, mass concrete now has become more prevalent in that it's the definition according to ACI is no longer just how big something is. Mass concrete is now defined as the geometric size, how big something is, and how much cement content is in the mix design. In theory, and there's a table out there that you can look at, in theory, you could have something that's 6 inches deep, but you have 1,000 pounds of cement in that mix design. That is enough cement to induce a lot of heat that could be deleterious to that concrete that you're pouring in that 6-inch slab. That's never going to happen, but that's the worst case scenario in this table. So what mass concrete now has devolved into is that there used to be, and there still is, specifications in mass concrete that two things were historically looked at. One is the maximum temperature that element has gained as it's curing. And I don't know where this originated from, but that number is like, say, 160 degrees or 165 degrees. People have tailored mix designs to keep that high temperature below 160 or 165. There's also another element which is called temperature differential in mass concrete, and that's the difference between what's at the surface of the concrete and what's at the very middle. That number has historically been 35 degrees. There are ways to essentially keep the heat in to keep that differential down. Now, what just in the past little while, maturity has come into play in the fact that, and it more has to deal with this differential thing that I was talking about. In a mass concrete element, there is a thing called a performance-based temperature differential limit, or PBDTL. And that some engineers now have a way of determining that when you first pour this mass element, your differential may be in the 20 degrees, just making numbers up. But as that concrete gains strength, that differential limit then can rise. And the whole point of it is, in a very general sense, the stronger concrete gets, the more resistant it's going to be to those thermal stresses being placed upon it. You now have a way of determining how strong that concrete is in real time and comparing that against this performance-based temperature differential limit that has been created. So again, it is all about efficiency. It's all about knowing what's going on inside the concrete in real time.
So if I'm hearing you right, so there's requirements out there for mass concrete, which mass concrete is just typically it's a very large pour, a big foundation or large column or something like that. But you're saying now that there's a cement amount that may push you into mass concrete, even if it doesn't fit within those concrete size parameters. Correct. And then when you get into some mass concrete, whatever's, if it's defined as mass concrete based on those two parameters, size or cement content, there is a requirement for the difference in temperature between the concrete poured and the ambient temperature.
No, it's the surface of it. So you're taking measurements inside the concrete. So the worst case scenario, the coldest spot is going to be up towards the surface, out towards a corner, because that's where more heat's going to be lost in the initial period of curing. And then the very center or geometric center of that element. You're taking the differential between the worst spots possible.
Gotcha. On the surface of the element, we'll just call it an element, and then in the middle of it, so it's core.
Yes.
Okay. The difference between those two things, you got to keep them within a certain temperature difference between the two, based on the strength of the concrete. There's a chart that tells you if it can be like 20 degrees or 40 degrees or whatever. Yeah. What a pain in the butt. Someone figured out that it creates a problem. So yeah, that I could see that being used. So where do you see these jobs? Is there a type of job that you see those requirements for mass concrete?
It goes across the board. On commercial projects where mass concrete is involved, it's something like a pile cap or a linear accelerator in a healthcare facility. And then all over the civil world, bridges, lock and dams, naval facilities. And let's just throw that one out there just because I was just talking to someone about that the other day. Sporting stadiums. Seth and I were just talking about the new Buffalo Bill Stadium. That's got a lot of mass concrete elements in it.
I was shocked. I was reading a spec the other day. It was a federal job, base job, and it had maturity meter spec'd in it. I had to read it twice. I was like, what? Because usually you think those are the last guys that would jump on board.
You have to share that info now.
Yeah, so that's great. Is there any other application other than the mass concrete that you wanted to talk about? So we talked about post-tension jobs. So there's a requirement before you pull the post-tension cables. It's got to reach a certain strength. There's jobs that don't have post-tensioning or do have post-tensioning that you're not allowed to remove formwork till it reaches a certain strength. And now where we just talked about the mass concrete, where you got to know the high temperature and the low temperature on a piece of concrete, and you got to make sure the differences between those two things aren't beyond what is specified. Anything we missed?
Correct. Just some secondary things that people sometimes don't think about. In colder weather, if, like, say, you're on the 16th floor of a high rise, and if you're in a colder climate, I've seen it to where they'll tent that entire pour and then apply secondary heat from the floor below. Those big jet engine heaters. Granted, it's not a big thing, but you can know when to turn those heaters off, or when you can take the tenting down, because once it reaches a certain strength, you don't necessarily have to keep heating it. So,
yeah,
like I said, it's a small thing, but again, it's just having that knowledge available to you and in real time.
Yeah. All right. Is there anything else we need to cover?
No, I think we've talked enough.
Okay. Well, Mark, I appreciate you coming on the show. If folks want to reach out to you and learn more about the maturity meter technology, what's the best way to get a hold of you?
Phone number is 314-713-1107. And my email address is mchase, M-C-H-A-S-E, at RPX Tech, and that's TECH.com.
Okay. And as always, we'll put it in the show notes. So we'll put Mark's contact information on there so you have it too. You don't have to write it down while you're listening to Mark. But all right, Mark, I appreciate you coming on the show today. And folks, until next time, keep it concrete.